the exercises on solid mensuration in exercise 20.1. Now, question 6 says, the diagrams below show the cross-sections of solids. If the length of each solid is 10 centimeters, find their volumes. This is simple. To find the volume of each solid, we just find the cross-sectional area we are given. We find the cross-sectional area of the shape we are given and multiply that cross-sectional area by length. I hope you can see this. Let me change it to green. We find the cross-sectional area of the shapes we are given, and multiply our answer by length. So here, this cross-section has two parts. It's a rectangle, but from the rectangle, majorly it's a rectangle, 28 by 24. But from the rectangle, a semicircle has been cut out. Let me use a red line. A semicircle has been what? Cut out, meaning that to find the area of the shape, I'll find the area of the rectangle and subtract the area of the semicircle from it. I'll find area of rectangle minus area of semicircle. That will give me the area of the shape. So the area of the rectangle is length times breadth, 24 times 28. The area of the semicircle is half the area of a circle. That's half times pi r squared. What does that give me? Length times breadth minus half pi r squared. That gives me what? That gives me my cross-sectional area here. After subtraction, I'll get the answer for each part, subtract, get my final answer, multiply that final answer by 10 to get my answer in centimeters cubed. That's the volume of the shape or solid in 6a. Question 6b. The cross-sectional area is a triangle. So the area of the triangle is half AB sine theta. Area of a triangle is half AB sine what? Theta. That's half times the product of the two sides given times the sine of the angle between them. Half AB sine theta is the area of this triangle. So we multiply that area by the length of the solid to get the cross-sectional, to get the volume of the solid. So you put your answer here. After evaluating, you put your answer here. That gives us the volume of the solid. In 6b. In 6c, the solid has a parallelogram as its cross-section. So its volume will be its cross-sectional area times length. The area of this parallelogram is AB sine theta. That's what? 8 times 12 times sine 125. We multiply that area we get by the length of the solid to get our volume. Now, question D. The cross-section of the solid in D is a composite shape. So we split it into pieces. We split it here. This part is A, this part is B. Split it here. This part will be C. Each part is a rectangle. So we get the dimensions of the rectangle. As you can see from here, this will be 6 times 2. Let me show you. 6 by 2. That's the dimension of A. That the dimension of B will be 3 by 2. It's also a rectangle. The dimension of C will now be what? 6 by 2 also. So you put each of them in brackets separately. Length times breadth. Get your answer for each bracket. Get your answer for each bracket. Add the areas you get the total cross-sectional area, and multiply it by the length of the solid to get its volume, 300 centimeters cubed. In question 7, the cross-section of a prism is a right-angled triangle, 3 centimeters by 4 centimeters by 5 centimeters. The question says calculate its volume if its length is 8 centimeters. So all you need to do is simple. We find the area of this cross-sectional triangle. We find the area of this triangular cross-section like this. That's what half base times height. The base is shown, half base. This is the base times height, which is 4. The base is 3. So we get the area of cross section, multiply it by 8, and that gives us the volume of the shape. So question 8, a water tank of height 0.5 meter has a square base of side 1.5 meter. A square base of side 1.5 meter will be here, 1.5 meter by 1.5 meter. Can you see that? So the question says if the height is 0.5 meter, it says calculate its volume. It says if it is filled from a water tank that's holding 1,500 liters, how many liters of water are left in the water tanker? So all we need to do is simple. Find the volume of our tank. So length times breadth times height will give us what? 1.125 meters cube. We now change that meter cube to liter. From meter cube, 1 meter cube is 1,000 liters. Let me write that here. 1 meter cube is 1,000 liters. So we'll change our volume to liters by multiplying it by 1,000. That gives us what? 1,125 liters. So if the tank is filled from a water tanker that holds 1,500 liters of water, subtract the volume of the tank from the volume of the water tanker, you get the volume of water remaining. This is the volume of the tank, this tank, and this is the volume of the water tanker. So we did the subtraction to get the volume of water remaining. That's question 8. In question 9, it says a cylinder of base radius 4 cm is opened at one end. If the ratio of the area of its base, a cylinder of base radius 4 cm is opened at one end. If the ratio of the area of its base, to that of its cut surface area is 1:4, calculate the height of the cylinder. That's a simple question. Base area, this is the base of the cylinder. Base area over curved surface area is 1/4. That means base area is pi r squared. The curved surface area is what? 2 pi rh. So that means pi r squared over 2 pi rh is equal to 1/4. What does that give you? That gives you r, you simplify this, you get r over 2h is 1/4. So 4r is 2h. And in the question, we are told that the radius of its base is 4 centimeters. R is what? 4 centimeters. We've been given that here. So that means the height of the cylinder will be 2 times 4, which is what? 8 centimeters. Take note of how we did this. Base area over cross-sectional area is 1:4 or 1/4. Base area is pi r squared. Cross-sectional area is curved surface area is 2 pi rh. So pi r squared over 2 pi rh is 1/4. This means pi will cut pi, r will cut r. Then you have 1r over 2h left. You have this r over what? 2h left. So r over 2h is what? 1/4. So that means h is 2r. Now we cross multiply. Excuse me. R over 2h. R over 2h is 1/4. That tells you that if you cross multiply, 2h will be 4r. And what? 2r will be h. H is 2r. So simplification, h will be 2 times 4. That's number 10. Sorry, that was number 9. Number 10 says the area of the curved surface of a solid circular cylinder is 165 centimeters squared. The formula for curved surface area is 2 pi rh. That means 2 pi rh is 165 centimeters squared. The question says if the height of the cylinder is 5 centimeters, find its radius. Very simple question. 2 pi rh is 165. So we know h, but we don't know r. So substitute and cross multiply. You get your r. That was a simple question. Number 11 says calculate the surface area of a hollow cylinder which is closed at one end. If the base radius is what? 3.5 centimeters and the height is 8 centimeters. Okay, let me check something. Okay, my mistake. All right, calculate the what? Number 11 says calculate the surface area of a hollow cylinder which is closed at one end if the base radius is 3.5 centimeters and its height is 8 centimeters. So if it is closed at one end, that tells us that the base is closed but the top is open. So the total surface area of the cylinder will be area of base plus curved surface area. There will be no top. The base has an area of pi r squared. The curved surface area is 2 pi r h. So that gives us pi r open bracket r plus 2h. Pi r open bracket what? R plus 2h. So that will be what? 20 over 7 times 3.5 r plus 2 times 8. So you simplify to get your answer. This is my answer for the total surface area or surface area of the cylinder opened at one end. Let's go to number 12. In number 12, it says an iron rod has a diameter of 3.5 centimeters. If the diameter is 3.5 centimeters, you divide that by 2 to get its radius. 3.5 over 2 will give you 1.75. The question says that, and its length is 5.5 meters. 5.5 meters is what? 5.5, 5.5, that's 5.5 times 100. That's what? 550 centimeters. So that's what? 550 centimeters. So the question says we should find the density if its mass is 41.82 kilograms. If the mass of the rod is 41.82 kilograms, find its density in grams per cm cube. So very simple. First thing is to get its volume. Its volume will be base area times height or length. The base area is pi r squared. Since the radius is what? Since the radius is 1.75, so pi r squared times height will give us the base area. Will give us the volume. Base area times what? Height. Now the base area times height will give us 5,293.75 centimeters cube. That's the volume of the rod. After getting the volume, we now go to density is mass over volume. So the density of the solid will be mass over volume. The mass is 41.82 kilograms. Change 41.82 kilograms to grams by multiplying it by 1,000. That gives you what? 41820 grams. Divide 41820 grams by the volume, which is 5,293.75 centimeters cube. You get your answer, 7.9 grams per cm cube to 1 decimal place. To 1 decimal place. That's the end of exercise 20.1 on solid mensuration. I'll give you an exercise in the next video before we start the second exercise.